Hello everyone, welcome to the one-shot video on digital electronics. Let us start with number system and representation. In this topic, we will understand what are the different types of number systems and how to represent them or convert them from one system to another. So let us start with decimal to binary number system. In decimal to binary number system, we must first of all know that the decimal number system has a base 10. And the binary number system has a base 2. So, if you are given a number like 5 having a base 10, that means you are asked to convert a decimal number system because the base is 10, and this is how you know that it is a decimal number system, and you are asked to convert it into binary because the base of the system is 2. So, binary has a base 2. And if any number system or decimal number system having a base 10, it means that in decimal number system you can represent numbers from 0 to 9 because the base is 10. So if the base is n, we are able to represent digits from 0 to n minus 1. So in the case of decimal it is 10, therefore we are able to represent from 0 to 9. So 5, that is the question, given question. You are asked to convert a decimal number system to binary. So let us see the method. Just start dividing 5 by 2. 1 is not divisible by 2, therefore quotient is 0, remainder is 1. So until and unless you receive 0 over here, keep on dividing. Once you receive 0 at this particular place, that means at the place of quotient, then you have to stop and record the answer. The answer has to be recorded from bottom to top, not from top to bottom. So the answer is 101 when we are moving from bottom to top and with the base 2. This is how we converted decimal number system to binary. If this, now next question, if this decimal number system is in points, that means you are not given a whole number, in fact you are given number after decimals. So, and you are asked to convert it into binary. So what will be the method? Instead of dividing it by 2, you have to multiply it by 2. So 0.61 will give you 1.22. Now you have to record this whole number, that means 1 gets recorded and the remaining is 0.22. So again multiply it by 2, it will come 0.44. The whole number is 0. So the process will go on. Here you are recording this 1, here you are recording this 0, and you have to stop till 4 decimal places and record your answer from top to bottom. So the final answer is, so this is how we convert the decimals to binary. So if you would have been given the question 5.61 in decimal number system and you are asked to convert it into binary, so 5 has to be converted in a separate strategy and 0.61 has to be converted with a separate strategy as shown above, and then you can combine your answers. I hope you understood this. Now in the same way, let's understand how to convert binary to decimal. So how to convert it? First of all, you have to take, first of all we are only talking about the whole number, that means before the point. So the direction for this will be from right to left, and for after the point or the decimal part it will be from left to right. So first of all we have to mark these arrows. Now let us solve only this part. Alright, now here we have marked the direction from right to left. So let us move in this direction and take the digits one by one. So the first digit is 0 and multiply it by the positive powers of 2. So positive power will start from 0, add plus, again take the second digit 0 into 2 raised to the power 1. So we will get, the answer will be 28. So we have solved this particular part. Now let us solve after the decimal portion, and we have marked the direction as from left to right. So let us see. Let us take the digits in the left to right direction and multiply them with the negative powers of 2. Solve it, you will get it like this. So let us combine both the things. So this is how we solve the case from binary to decimal. So these are the two basic cases, that is decimal to binary and binary to decimal. Always remember these methods. The same methods will be followed in the other conversions as well. So let us see the other conversions. The other conversion is decimal to octal. So if the decimal to octal conversion has been asked, octal has a base 8. First of all, you have to remember this as well. So if in any of the conversions you find decimal number on either of the side, please mark my words. If in any of the conversions you find decimal number system on any of the sides, either left or right, then you have to follow the same method that was followed while converting from binary to decimal or decimal to binary. I mean to say that if you are finding decimal number system on the left, as is the case over here, then you have to follow the same method as was followed while converting decimal to binary. If you would have found decimal number system on the right hand side, that means you have to follow the same process that you followed while converting from binary to decimal, because the decimal number system is on the right side this time. So let us now come back to the question again. This time the decimal number system is on left. So we will follow the same process that we followed while converting from decimal to binary. And the process was, we started, first of all, we are going to take only this whole number part. And how to convert it into, did we convert it into binary? We divided it by 2. So in this particular case, we are going to divide it by 8. So in place of this particular place, we received 0. That means we have to stop here, record the answer from bottom to top. So the answer is 366 for this particular portion. Now let us solve for 0.32. What was the method in the case of decimal to binary? We multiplied it by 2. So here we will multiply it by 8. The answer from top to bottom, and the complete, so it is 0.241. And the complete answer is, this is how we convert decimal to octal. Now let us take another conversion, that is octal to decimal. This time the decimal number system is existing on the right hand side. So we will follow the same method as we followed while converting from binary to decimal. If there is no decimal part, so the direction will be from right to left. Alright. So it is, and then while taking each digit, we will multiply it by the positive powers of 8. This is how we write the answer. So this is the conversion from octal to decimal. The next type of conversion is decimal to hexadecimal. How did we convert it? In this case, we will keep on dividing it by 16. One very important thing, hexadecimal has a number system 16. That means you must be understanding that you are able to represent numbers from 0 to 15 in hexadecimal number system. So when you are able to represent from 0 to 15, 0 to 9 numbers will be represented as it is. But when you have got 10 in hexadecimal number system, it is not represented as it is. In fact, 10 is represented as A, 11 as B, and finally 15 as F. So in the case of hexadecimal number system, if you are having any number which is from 10 to 15, you will not be representing it as it is. In fact, you will be representing it by the alphabets. So 16, let us divide it by 16 too. So now we received 0 at this place. We have to stop it, record the answer. Again, let us take one more example. So instead of dividing it by 16, this time we are going to multiply it by 16. Record the answer from top to bottom. So the answer is 0.122 in decimal number system is represented as 0.1F3 in hexadecimal. So this is how we convert decimal to hexadecimal. Now another conversion from hexadecimal to decimal. That means we have to follow the same method that we followed while converting from binary to decimal, because decimal is on right hand side this time. So first of all, decide the direction as we decided in the case of binary to decimal, and let us take the digits one by one. So I am solving this particular part first of all and multiply it with the positive powers of 16. This part we have solved. Now let us solve the other part, that is F27. So F into, okay, so the complete answer is 2AF.F27 in hexadecimal when converted to decimal came out to be. So this is how we converted hexadecimal to decimal number system. Now let's move on to another conversion, that is binary to hexadecimal. Now here we do not have decimal number system on either side. Therefore, we have to remember the method separately for this case, which is very simple. So what we have to do, first of all, we have to mark the directions binary to hexadecimal for the case, and we have to see hexadecimal means the base is 16, alright. That means 2 raised to the power 4 is equal to 16. So the code for hexadecimal is 8421. From where it came? 2 raised to the power 0 is 1. 2 raised to the power 1 is 2. 2 raised to the power 2 is 4. 2 raised to the power 3 is 8. So from here comes a code, that is 8421. When you will sum this 8 plus 4 plus 2 plus 1, you will get 15, which is the maximum number that can be represented in hexadecimal number system. So what you have to do, as you can see, I have marked the direction for both the portions before the decimal and after the decimal. One direction is from right to left, and for after the decimal part, it is from left to right. So now moving in the same direction, we have to make groups of 4. So I moved in the direction from right to left for this particular part, and I made a group of 4. Why 4? Because our code is a group of 4. And the next part which is left, 0, 1, 1, remains short of 1 digit. So I will add a 0 here and make it a group of 4. Now this is first group, this is second group. I will place now these groups under this code 8421. So my first group was 0110. Now the 1, this one is falling under 4 and this one is falling under 2. Sum them up. 4 plus 2 is 6. So this number represents 6. So this is 6. Same again, 0110 is again the same combination, so it will give you 6. Now for the after decimal portion, what you have to do? You have to move in this direction and make a group of 4 again. So here I made a group of 4, and for the next group, I am left with only 2 digits, so I have to add 2 others, zeros. Now 0110 is again 6, and 1000, let us place it under 8421. 1 is lying under 8, so this number is 8. So this combination is 8. So the answer is in decimals. So this is how we represent binary to hexadecimal. I'm sorry, binary to not decimal, it's hexadecimal. So now let's move on to hexadecimal to binary. Okay, so for hexadecimal the code is 8421. If you have to represent F, now F means 15. So for 15, you have to mark 1 such that the sum of these numbers will give you 15. So 8, 4, 2, 1, 8 plus 4, 12, 12 plus 2, 14, 14 plus 1, 15, all will give you 15. Alright, that is F. E means 14, and for 14, you have to place 8, 4, 2, 1110. 8 plus 4, 12, 12 plus 2, 14. Then for A is 10. For 10, you have to get 1 under 8 and 2. 8 plus 2 is because 10. So it will 1010. So simply the answer is 1111 1110 1010. So this is how it gets converted. Very, very simple. Now let us see another conversion, that is binary to octal. Octal base is 8, alright, and the code this time is 421. Instead of 8421, that was the case for hexadecimal, it is 421 in the case of octal. 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2. When you will sum them up, it will come out to be 7. That is the maximum number that you can represent in octal number system. And now you have to specify the directions. Moving in these directions, this time you are going to make groups of 3 instead of group of 4. Here we are left short of 10, so we will place it. So when you will place this group under this 001, so that means it represents 1. 001 again 1, 010 that is 2. 011 that is 1 is under 2 and 1, that is 2 plus 1 3. 001 will give you 1, 010 will give you 2. So the answer is 1 in the case of octal. So this is how we convert binary to octal. Next comes octal to binary. Alright. So again, for the octal number system, code is 421. You simply have to represent each number for with this code. So for 1, it will be 001. For 2, if you have to represent, so you have to place 010. For 3, it will be 011. 5, it will be 101. For 6, it will be 110. And for 7, it will be 111. So the combined answer is, this is the combined answer. So I hope these conversions are clear to you. Now the last conversions that are left is hexadecimal to octal and octal to hexadecimal. What you have to do over here is, you have to follow 2 steps. First step is the conversion of hexadecimal to binary, and then from binary to hexadecimal. So these are the binary to octal. So this is how you have to do hexadecimal to octal or octal to hexadecimal conversions. First step is to convert hexadecimal to binary, which we have seen. Hexadecimal code is 8421. Alright. So B represents 11. And for 11, we have to place 1 under 8 and 2 1. 8 plus 2 10, 10 plus 1 11. So 0 means 4 times 0 and A means 10. So 10 means 1010. 8 plus 2. So this is how we converted it into. First step is over. Now second step is to convert it into from binary to octal. For octal number system, we have 421 code. That means we have to specify the directions first and makes the group of 3 3 in these directions. So this 010 will represent, if you will place it in under 421, it will represent 2, 111 will represent 7, 011 will represent 3, 000 will represent 0, 010 will represent 2, and 100 will represent 4. So 273.024 is the final answer. Same method will be followed while converting from octal to hexadecimal. Octal to hexadecimal. So take a question from me and comment in the comment box what are your answers. Octal to hexadecimal. I am giving you the question. Follow the same method as I have told you above and comment in the comment box. I will be waiting for your answers. So this is the question. So that was the number system. Now let us understand Boolean algebra. In Boolean algebra, first of all, we will be understanding some of the laws, and using those laws, we will be solving or minimizing the Boolean expressions. So let us understand the laws. The first law is AND laws. Whenever we will talk about AND laws, that means we will be talking about multiplication laws. So in normal mathematics algebra, a dot 0 or any variable when multiplied by 0, it gives 0. Same is the case here also. In AND laws, first formula is a dot 0, which is 0. Very simple. A dot 1 is equal to a. A dot a bar. What is a bar? See, we are talking about digital electronics. In digital electronics, mainly we talk in terms of 0 and 1. That means if we are taking any variable, let's say a over here, that means it can only have two values, either 0 or 1. So a dot a bar means if a is 0, a bar is 1, or if a is 1, then a bar is 0. That means a bar is the complement of a. So when a is multiplied by its complement, then it will give you a 0. Then a dot a. In normal mathematics algebra, a dot a will give you a square. But in this particular case, a dot a will give you a. Because a can be either 0 or 1. If 1 dot 1, then also 1. If 0 dot 0, then 0. So these are the AND laws. Now OR laws. Whenever we will talk about OR laws, we will be talking about addition laws. So a plus 0, as in normal mathematics algebra, anything when added with 0 will give you that particular value. A plus 0, a. A plus 1 will give you 1. Because again, a can be either 0 or it could be 1. So if a is 0, then 0 plus 1 is 1. And if a is 1, then 1 plus 1 is not equal to 2, because this is digital electronics. So 1 plus 1 is equal to 1. A plus a bar is equal to 1. Why? Because if a is 1, then a bar will be 0. So 1 plus 0 will give you 1. Or if a is 0, then a bar will be 1. So 0 plus 1 will again give you 1. Then a plus a. It will not be 2a. In fact, it will be a. Because 0 plus 0 is also 0 or 1 plus 1 is also 1. So a plus a will give you a. So this is AND laws is the first law. Second is the OR laws. And the third one is De Morgan's theorem. De Morgan's theorem. De Morgan's theorem states that if you encounter any expression like this where you get an addition of some variables with complete complement over them, then you can separate the variables with individual complements, but the sign between them will get reversed. Reversed means if in the original expression it was plus, then it will become dot. And similarly, if you encounter an expression with a product sign and complement over the complete expression, again you can break them into individual variables with the complements and the sign will get reversed. So very simple and important De Morgan's theorem. Another law is very simple, C plus AD. If you encounter any such expression like this, so we can break it into C plus A dot C plus D. So these are the only 4 Boolean laws or Boolean laws of the Boolean algebra that we have to follow while minimizing any expression. So very important, we only have to follow these 4 laws and minimize the expressions. So let us start minimizing the expressions. So let's say we have an expression, alright. So let's minimize it. Let me take some things common. So I'm going to take b bar c and b bar c common from these two expressions. I will be left with a bar plus a, and from here we can leave it as it is, because taking one variable common is of no use. It will not minimize anything inside the bracket. So b bar c, a plus a bar is 1, so we are only left with b bar c, because dot 1 will be b bar c itself, and plus a bar b c bar plus a b bar c bar. Now b bar c plus, I am taking c bar common from here, a bar b plus ab bar, which is of no use. So the expression over here will be like this: b bar c plus b bar c plus a bar b c bar plus a b bar c bar. So I am taking b bar common from here and here. So b bar common, c plus ac bar plus a bar bc bar is equal to b bar. Now I am applying the fourth law, which will minimize the expression to some extent, bar b c bar. Now b bar, this reduced to 1, so b bar c plus a bar b c bar. I will open the bracket, a b bar plus b bar c plus a bar b c bar. So I don't think that it is further possible to reduce the expression. So we have to continue until there is no option left to reduce the expression. So this is the final answer. Similarly, another question, let us see. This is another question. Let us minimize it. Let us take w bar, x bar, z bar common from here. So we will be left with 1 plus y bar plus y bar z bar plus yz bar. So 1 plus anything is 1, as we have seen in the Boolean expression, all laws. So w bar, x bar, z bar will be left, and from here I am taking z bar common, so y bar plus y, that is 1. So it will be w bar, x bar, z bar plus z bar, because this has reduced to 1. So now let us take z bar common, it will be 1 plus w bar, x bar, anything when added to 1 is 1, so z bar. So f is equal to z bar. This is the final answer. So this is how we solve very simply. If we understand the Boolean laws, we can solve the expressions or minimize the expressions very easily. It is very easy to solve them. Just we have to remember the 4 laws, that is OR laws, AND laws, De Morgan's, and the last law, that is C plus A AD expression, which we can break it into C plus A dot A, C plus D. Now let us solve another one, and I am giving you this as an assignment. You can comment in the comment box what answers you have got. So please do comment in the comment box what answers are you getting, and I will surely reply whether they are right or wrong. Alright, so you have to solve this question and comment in the comment box what answers you have all got when you minimized it. Now let us move on to the next thing, that is the logic gates. So logic gates, first of all, we should all understand that logic gates are basically of two types: basic logic gates and the universal gates. Basic and universal. When we talk about basic, in basic category comes AND gate, OR gate, and NOT gate. Under universal gates comes only two gates, that is NOR and NAND. Very, very important. Universal gates are only of two types, that is NOR and NAND gate are only considered as universal gates, and AND, OR, and NOT are the basic gates. First of all, let us understand why universal gates are so called. Universal gates are so called because you can realize any expression by using any universal gate individually. You do not need any other gate besides this universal gate to realize any expression. So You can realize any expression either by using only and only NOR gate, or you can realize any expression by using only and only NAND gate. You do not need any other gate to realize any expression. Now let us see their truth table and their symbols. First of all, let me show you AND gate. AND gate, the symbol of AND gate is with two inputs. This is the symbol. A and B are the inputs, Y is the output, and if Y is the output, then the expression is A dot B. Truth table is two inputs, therefore 4 combinations, and output is A dot B, therefore 0.00, 0.1 again 0, 1.00, 1.1, 1. So this is AND gate. OR gate, again with two inputs A and B. Symbol is curve, 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 3 curves, and the expression is Y equals to A plus B. Truth table is 4 combinations. Output gives you 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1. So this is OR gate. NOT gate. NOT gate has a single input and the symbol is in the form of a triangle and the output is A bar. That means A can be either 0 or 1. So Y will be, when A will be 0, Y will be 1. When A is 1, Y will be 0. This is NOT gate. Now let's talk about universal gates. First one is NOR gate. NOR gate, as you can see, is a combination of NOT plus OR. So first of all, let us draw OR. Curve, curve and curve. And NOR, in the case of NOR, you have a bubble. So it becomes Y equals to A plus B because OR and as a part of NOT bar. So truth table is 4 combinations and Y equals to A plus B whole bar. So 0 plus 0, 0, bar comes 1, 0 plus 1, 1, bar comes 0, 1 plus 0, 1, bar comes 0, 1 plus 1, 1, bar becomes 0. So this is the truth table for NOR gate. Now NAND gate. NAND is a combination of NOT and AND. So first of all, let us draw AND and then we will put a bubble. So it will become NAND. Y equals to A dot B and bar as a part of NOT plus AND. So truth table, A dot B 0.00 and bar is 1, 0.10 bar 1, 1.00 bar 1, 1.1, 1 bar. So this is the truth table for the NAND gate. So here are the logic gates. Now we only first of all classified the gates into two parts, that is basic and the universal. There is a third category as well which you must know, that is special gates. And under special gates we have two types of gates, that is XOR and XNOR. These also you must know because this will be very useful when you will go into the higher classes. So XOR and XNOR. So XOR, when we talk about XOR, it is exclusive OR. So exclusive OR, one thing implies that it has some part of OR. So let us draw an OR gate. For exclusive OR, one more curve, and this is the symbol of XOR gate. What is the expression? Pay attention. It is A bar B plus AB bar. So one time it is bar on A and for once it is bar on B. A bar B plus AB bar. Symbol is this. This is not an addition sign. This is XORing sign. Now let us draw the truth table. 4 combinations. Now you have two options. Whether you put all the values in this particular expression and solve it for each case, or there is a shortcut. The shortcut is such that, please listen carefully, if the two inputs are same, then the output will be 0. If the two inputs are different, then the output will be 1. So if two inputs are same, that is 0 and 0, so the output will be 0. If the two inputs are different, then the output will be 1. So when the inputs were same, either 0, 0 or 1, 1, the outputs were 0, and when the inputs were different, the output were 1. This is XOR. Now comes XNOR. XNOR is simple. It is the opposite of XOR. That means complement. So let us draw the XOR first and put a bubble at the end. The expression is A bar B bar plus AB. Symbol is XOR complement and the truth table is 4 combinations. Here the shortcut is the opposite. That means if the inputs are same, output is 1. If the inputs are different, output is 0. So this is how the gates work. So the main things that you have to remember for the current curriculum is that the logic gates are basically of two types, that is basic and universal. Most important ones are universal, which are only of two types, that is NOR and NAND. And the third category is special gates, under which falls XOR and XNOR. So these were the logic gates. Now let us understand K-maps, which is also called Karnaugh maps. So K-maps are different for different number of variables, and we will understand the K-maps from 2 variable to 6 variable. So up to 6 variable K-maps we will study. Now if you have to solve a n variable Boolean expression. So let us start by a general 2 variable K-map, and for example in the question you are given an expression like this and you are asked to solve it by K-map. Although you can solve it by Boolean algebra as well, but this time you are asked to solve it by K-map. So how to solve it? First of all, looking to any expression, you have to see whether it is of 2 variable or 3 variable or 4 variable, 5 variable or 6 variable. So as you can see in the given expression that there are only 2 types of variables in the expression, A and B. So it is a 2 variable K-map. Now what is the structure of 2 variable K-map? First of all, let us understand that if n is the variable, if you have to draw the K-map for n variable, then 2 raised to the power n will be equal to the number of blocks which will be drawn in the K-map. That means if in this particular question you have encountered that, or you have inferred that you have to draw a 2 variable K-map because this expression consists of 2 variables, then in that 2 variable K-map you will be having 4 blocks, because 2 raised to the power 2 will give you 4, and this is how you will draw the structure. Now as there are 2 variables, so you will draw a line, and the variable which comes alphabetically first you will write it downwards, and the variable which comes alphabetically in the next order you will write it upwards. Alright. Now these 2 rows, that means this particular area belongs to A and this particular area belongs to B. So A can have, in digital electronics, A can have only 2 values, that is 0 and 1. So this is A bar, or you can say 0, and this is 1, that means A. Similarly this is B bar, that means 0, and this is B. Alright. So A bar A, B bar B. Also you have to number the blocks inside the K-map. So if there are 4 blocks, the numbering will start from 0. So the range will go from 0 to 3. So 0, horizontal numbering has to be done, 0, 1, 2 and 3. So this is the basic structure first of all that you have to draw. Now when you have drawn this structure, see what is the first term. First term is A B bar. So A B bar means in front of A this block, and B bar means downwards. That means these 2 blocks for A, but for B bar only this particular block is important. So what we will do, we will mark 1 in this particular block. Similarly the next term is AB. The next term is AB. So AB means A in front of A and below B, that means this one. So we will mark this. Now when we have marked ones, what do we have to do? We have to group them in the maximum number. That means the maximum possible combination that is possible over in here is in a 2 variable K-map which consists of 4 blocks, that is a combination of 4 if all the blocks would have been filled. Alright. That means you have to see that what is the biggest combination that is possible in any variable K-map. Here 2 variable K-map. So 2 raised to the power 2 is the biggest combination which is possible. that is equal to 4. Combination of 4 is the biggest one. Then we do not have to search for the group of 3. Then we will decrease the power of 2 by 1. That means then a combination of 2 is possible. And if that is also not possible, then only a single one group will be made. So what we have to do, first of all, we have to search for the biggest combination. If it is possible, we have to make it. Otherwise, we have to search for the next possible combination, which is 2, and then we have to search for 1. So here, which groups can be made? The groups, only those can be made where the ones are in the adjacent blocks. So here, these two ones are in the adjacent blocks, so only this group is possible, and therefore we have made this group. Now there is no one left outside this group, so we do not have to bother further, and we just have to write the answer. What is the answer? First of all, look the side of A. So A is equal to 1 is that particular portion in front of which the whole group is lying. Alright. So in the answer A will definitely come. And if we look into the part of B, so B does not have any column which is common for both the ones. So therefore from the part of B nothing will come. So answer is only Y is equal to A. So this is how we solve the K-maps. I'll give you another question, try to solve it and write your answers in the comment box. Or let's solve it here itself. I'll give you further questions in the next higher variables K-map. So here also you can see that it is a 2 variable K-map. So what we will do, first of all we will draw the structure of 2 variable K-map. We will mention the variables. The one which has come alphabetically first, we will write it downwards, and the ones which has come alphabetically in the next order, we will write it upwards. Now this is B bar B and this is A bar A. Let's write the numbering 0, 1, 2 and 3. Everything has to be in the same order. If you will shuffle the order, your answer will be wrong. Now the first term is A bar B. A bar B, that means the one block, number 1 block. AB, that means which block? Number 3. AB bar, that means number 2. Alright, now we have to search for the groups. So the biggest group that we have to search for is 4, which is not possible here. Then we have to search for a group of 2, which is possible. Now, how is it possible? It is possible either you can group 2 or 3 number blocks, or you could have also grouped 1 and 3. But a combination of number 1 block and number 2 block is not possible because they are diagonal to each other. Only adjacent blocks can be grouped. So either you could have grouped 1 and 3 or 2 or 3. I have grouped 2 and 3 first. So this is my first group. Now I have to only bother about the one which is left outside the group. So outside the group only 1 is left. So in order to group it into the group of maximum ones, I can again make a group with 3. I do not have to, because again I will search for the biggest group, and it is possible when I will combine it with the third one. But we only have to bother this for only those ones which are left outside the group. Always remember that. So here 2 groups are formed. Let's write down the answer for the first group first. From the side of A, answer is A. And from the B side, nothing will come for the first group. So for this next group now, place a plus in between. And from side of A, nothing is possible. And from the side of B, it's B. So Y equals to A plus B. This is how we get the answers. So this was 2 variable K-map. Let's move on to 3 variable K-map. So 3 variable K-map. Again, let us see the general structure. First of all, 3 variable K-map means obviously there will be 3 variables in the expression, and the number of blocks that we are going to draw this time is 8. So this is how we will draw. This is the structure. Now how to allot the variables? Here only one variable will come, which is alphabetically first in the order, And for the higher order alphabets, we have two variables now because total 3 variables. So the higher order 2 variables will be placed upwards. Now this is A bar A, that is the same, or you can say 0 1. And for here the combination will be the same as you make in the truth table, 0 0 0 1, but 1 0 will be by leaving one column and 1 1 again coming back to it. Alright, now let's do the numbering. The numbers will range from 0 to 7. So 0 1 horizontal numbering, but 2 will not be adjacent to it, just leave it. 2, then 3, 4, 5, 6 and 7. This is how we do the numbering. Now this is the general structure for a 3 variable K-map. Let's do a question. The question now has taken the form. Let's do a question in this particular form. F bracket ABC. Now clearly by looking F bracket ABC, that means F is a function of 3 variables A, B, C. So you can easily see that it is a 3 variable function, and you are given the min terms. Min terms you can easily understand that with summation m small m means min terms. Alright, this is summation. Summation means sum. Why it is sum? Because whenever you write for the next group the answers, you place a plus in between. So this is sum of product. You can understand it like this. So min terms means you have to fill 1 in these number of blocks. So let us draw the 3 variable K-map structure first of all. Do the numbering, and now let us fill the ones. So 1, 2, 4, 5 number blocks. 1, 2, 4 and 5. Now let us fill them up. Let us make the combinations. The biggest combination that we have to search over here is 2 raised to the power 3, that is of 8. Is the group of 8 possible? No. Then we have to search for the group of 4, which is again not possible because we do not have adjacent 4s. Then we have to search for a group of 2, which is possible. How is it possible? Either you can make a group of 1 and 5 or 4 and 5. Alright, so let's make any of them. I am making 4 and 5. Now I have to only bother about the ones which are left outside the group. That is 2 and 1. For the sake of the one which is lying in block number 1, I will make a group of 2 by combining it with the block number 5. But the one now which is left in block number 2 cannot be grouped with anything because it does not have a 1 here or any other possibility which I will tell you later. So therefore this one will be left unpaired. That means at the last we will make a group of 1 if its grouping is not possible. So this is also another group which is only of 1. Now let us write down the answers. Let us mark it as was first group, this is second group, this is third group. Now let me write the answers for all the groups. For the first group the answer is A, B bar only. Why? Because the whole group is lying in front of this. So this is A. Now the whole group is lying under 0 0 and 0 1. What is common in between these two? This 0 and this 0 is common. So this 0 belongs to B, and if it is 0, so it is B bar. Now for writing the answer for the second group, I will place a plus in between, and for the second group I will write from A part nothing will come because nothing is common, and from the BC part B bar C will come. Same for the third group, A bar B C bar. So this is the answer for this particular expression. So this is how we use the K-maps. Let us do one more question. FABC equals to summation M 0 2 4. Let us do it. So as you can see from the question itself, it is a 3 variable K-map. Let's draw it. Let's do the markings. And let's place the ones. 0, 2, 4 and 6. Now again the same method. First of all search for the group of 8. We can't find it. Then search for the group of 4. We can't find. Yes, for the group of 4. So what you will say? You will obviously say, no, we can't find a group of 4. But that is not the case, and that is what I would like to teach you in this through this particular question. See, you have to check the corners also. As you can clearly see over here that the two ones are lying in 0 and 4, and on the opposite corner the two ones are lying on the corresponding blocks. Corresponding means the corresponding block of 0 is 2 and the corresponding block of 4 is 6. So that means if you can group 0 and 4, you can also group 0, 2, 4 and 6. That means always check the corners. So this is a group of 4, biggest group we have to make, and only one group is made. So first of all we searched for a group of 8, which was not possible. Then we searched for the group of 4. That is why I am saying again and again, search for it. So anything that is easily visible to you is the correct answer. That is not mandatory or that is not necessary. You have to search for it. So when you will search, you will intentionally see whether the corners can be grouped or not. So here it can be grouped and it becomes a group of 4, single group. Now the answer is y equals to, from A part nothing will come because 0 and 1 both are uncommon. From BC part, these two columns are here under which the whole group is coming, and amongst it this 0 is common. This 0 belongs to C and therefore it is C bar. So the answer is y equals to C bar. So this is how we solve the 3 variable K-maps. Now let us move on to the 4 variable K-maps. For 4 variable K-maps, first of all let us see the structure. So for 4 variable K-maps, how many blocks will be there? If you are watching the video, then kindly comment in the comment box that how many blocks will you draw in the 4 variable K-map. So 4 variable, that means A, B, C, D. The ones which comes first alphabetically will be written downwards, and ones which are coming higher in the order, they will be written upwards. Combinations will be same. Now mark the blocks. The range will go from 2 raised to the power 4, that is 16. So the range will go from 0 to 15. The 0, 1, 2, 3, 4, 5, 6 and 7 till like this we have done in the 3 variable as well. Now the third row we have to leave 8, 9, 10, 11, 12, 13, 14 and 15. Okay. Now let's do a question and try to solve. So f a b c d is equal to summation small m 0, 1, 2, 5, 13 and 15. So this is the question. Let's try to solve it. First of all, let us draw the common structure and mark the 1. Now let us see how to group them. Again the rule remains the same. The maximum group that is possible over here is a group of 16, because here it is a 4 variable K-map. So 2 raised to the power 4, 16 is the maximum group which was possible. But we do not have ones filled in all the blocks, so it is not possible. We will search for then 2 raised to the power 3, that is a group of 8. Again that is not possible. We can't see a group of 8 over here. Then we will search for a group of 4. I don't think even that is possible. Then we will search for a group of 2. Let us see. So there are many groups that can be made in a group of 2. Like we can combine 0 and 1. We can combine 1, 5, 5, 13. 13, 15 also can be combined. And 2 can be combined with 1 according to the law that we have seen in the previous question, that even the corners can be combined. Alright. That means if we have corresponding ones in the corresponding corners, they can be combined. So there are many possible combinations. So when such is the case, what you have to do, in order to avoid reluctancy, what is to be done? First of all, you have to group only those ones. Okay, I'll tell you the possibility that will come first of all in your mind, then I will tell you the correct answer. So looking to this question, first of all, we will see what we have encountered, that only a group of 2 is possible. So in a fast manner we will draw these group, we will draw this, or some people can even do 1 and 5, 5 or 13, or 13, 15, and 0 and 2. Alright, so what happens over here is this, that you can make redundant groups. Redundant groups means extra groups which are not required. How can they be made? Let me tell you the correct thing. And we were having the ones over here. Now, for this particular case, where a lot of where only the groups of one sizes are possible, and there are many groups that can be formed. There are many possibilities. So when such is the case that there are many possibilities with the same size of groups, then what you have to do, first of all, you have to make those groups which are possible only for one manner or one case. That means if you will see the number block 15, so the one which is lying in block number 15 can be grouped only with the block 13. It cannot be grouped in any other way. So when the possibility is only the one, you have to group those cases first of all. Alright. Similarly, the one which is lying in block number 2 can be only grouped with the block number 0. There is no other possibility for that. Now, as I have told you earlier also, we have to only bother for the ones that are lying outside the group. So those are 1 and 5, and they can be grouped together. So a total of 3 groups have been made, isn't it? But if you were confused, as in the previous case, some people would have formed 4 groups, some people would have formed 3 groups, and there was no clear concept that what to do. It was just a fluke. So when a same size of group is possible for many cases, so what you have to do in order to avoid any confusion and redundancy, first of all, you have to form those groups which are possible only in one manner. Alright, so this is how we do it, and just then we have to write the answers. For the first group, if we see, the answer will be, I hope you all can see the first group. So from A side, it will be A bar. From CD side, it will be C bar D. Second group, AB. From CD part, it is D. Third group, A bar B bar, and from CD part, it is D bar. So this is the answer. So this is how we solve the questions, such questions. So please solve them carefully. I am giving another such question. Just solve it on your own and write the answers in the comment box. Surely, please make sure that you write your answers in the comment box. I will be very happy to see your answers, and I'll surely reply whether they are right or wrong. Thank you. So the next question is, you have to solve it on your own, and it is similar to the previous question. I am writing down the answer over here. Do comment in the comment box whether you have got this answer or not. So the answer for this question is, but just verify it once you are done. So this is the answer. Solve it on your own and verify it. Now let's solve another question. Let us solve it. As we can see from the question itself that it is a 4 variable K-map, because f is a function of 4 variables. So let's draw the structure of 4 variable. Do the numbering inside the block. Now mark the ones. Now let us see which possible combinations are there. First of all, we will search for a group of 16, but that is not possible. Then we will search for a group of 8, again not possible. Then we will search for a group of 4, which is possible, and I hope everybody can see it. Now we will only bother about the ones which are left in block number 3 and 11, which is outside the group that we have made. Let us see how we can combine them in the biggest group size. So 3 can be block 3 can be combined with block 1. That will be a group of 2. Is there any possibility to combine it in a group of 4? Yes, because 1 and 3 are lying on the corners, and let us check the opposite corners as well, and fortunately we find 2 ones over there as well. So it is possible to group them in a group of 4. If you will group them in a group of 2, your answer will be wrong, because you are not minimizing the expression then. Alright, then let it be second group, let it be the first group. Write down the answers for Then for the first group, from the AB side we'll get nothing because nothing common, but from CD side C bar D. From the second group we get B bar. From the CD group we get, sorry I have written it wrong, it will be 1 1 1 0, and this group will be made. So from AB side it is B bar, and from CD side it will be D. So this is the answer. So I hope you might have understood the main important points of 4 variable K-map, and this is the most important K-map, that is 4 variable. I am sure that the questions from 4 variable K-map will surely come in your exams. Now we have another very unique nature of question. Let us see what's it. The question is again of 4 variables, and you are also given some don't care conditions. So first of all, understand this properly, that D stands for don't care. As the word itself implies that you don't have to care about it, then the question arises that why is it then given in the question if we do not have to care about them. So let us see what they are used for. First of all, looking to the question, have we all realized that it is a 4 variable K-map? I hope yes, because f is a function of 4 variable K-map. So let us first draw the structure of 4 variable K-map very fast, and let's mark the main terms 1 1 3 5 4 7 9 11 13 15, and some don't cares are given, that is 12 and 14. So in the place of don't cares we put a cross. Now listen carefully what we have to do. These don't, first of all we have to follow the same rule, that are we finding any group of 16? No. Any group of 8? Yes. So I hope everybody can easily see a group of 8. Now we have to only bother about the one which is lying in block number 4 because it is outside the group. Now in order to combine it in a maximum group size, what we can do is, if we would not have any don't care condition in 12, block number 12, then 4 could have been only combined with block number 5 in a group of 2. But this time, due to this don't care condition, we will be able to group this one in a group of 4, which is what we desired, that the group should be of bigger size. So by using the don't care condition, we can group our ones in a bigger size group if these don't care prove to be useful. Now our don't care is left in a group block number 14, and we do not have to care about it. If it would have been 1 in block number 14 instead of don't care, we would have made a separate group for it, and we would have also written the answer for that group. But because this is a don't care condition, we do not have to bother about it, and we have to leave it as it is. So now we have two groups over here, group number 1, group number 2. Let's write the answers for both of them. For the first group, the answer is from AB side nothing will come, from CD side D will come, and for the second group, from AB side B will come, and from CD side C bar will come. So this is the answer for this particular question. So this was 4 variable K-map. I hope that you will be able to solve now other questions as well from your book or somewhere else. So this is how 4 variable K-maps are solved. Now let us move on to 5 variable K-map. For 5 variable K-map, first of all, let us see the structure. We will be having 32 blocks. So how 32 blocks will be made in the K-map? We have to make 2 4 variable K-maps adjacent to each other. And as we know that every 4 variable K-map or each 4 variable K-map consists of 16 blocks. So it will be total 32. 5 variable K-maps means there will be 5 variables A, B, C, D and E. So how to allot them? We all know that the smaller variable is placed downwards. So the downwards over here is here. A is placed here, and this K-map is A bar. This whole K-map belongs to A bar, that means 0, and this K-map belongs to A. A bar and A. Now 4 variables are left. The ones which comes alphabetically first will be placed downwards, and the others which are comes higher in the order, they will be placed upward. Combinations allotted. Now numbering. Numbering will range from 0 to 31. We already know how do we number a 4 variable K-map, that means till 15, and in the same manner we will continue here. So this is the 5 variable K-map. Now let us solve a question through this particular structure. The question is f a, b, c, d, e, that means f is a function of 5 variables. Minterms are given 0, 2, 5, 7, 13, 15, 18, 20, 21, 23, 28, 29 and 31. So let us fill these minterms over here. 0, 2, 5, 7, 13, 15, 18, 20, 21, 23, 28, 29 and 31. Now how to group them? The rule will remain the same. First of all, you have to search for the biggest group, that is group of 32. That means 2 raised to the power 5. Is it possible? No, because for that all the blocks should have been filled by 1, which is not the case. Then you have to search for the group of 2 raised to the power 4, that is 16, which is also not the case. Then 2 raised to the power 3, that is 8. Now let us see to it. First of all, look only in the first K-map, that is above A bar. You can easily see that a group of 4 is made over here from the blocks 5, 7, 13, 15. Now your responsibility is to see the corresponding blocks in the adjacent K-map as well. Alright, that means if the corresponding block of 5 is 21, 7 is 23, 13 is 29 and 15 is 31. If you find the same blocks filled with 1s, then a group of 8 can be formed by overlapping. As you can see, a group of 8 can be formed. Let us mark it as group number 1. Now we have to only bother about the ones which are left outside the groups. That means the one which is lying in 0 and 2. 0, 2. So for that, these are the corner ones. We can group them to 2, but we will search it for a bigger group. So is there any ones in 8 and 10? Because then corners can be grouped. No. Is there any corresponding one in 16 and 18? No, because in 16 it is missing. So only a group of 2 can be formed through this, and this is group number 2. Now the ones which are lying in the second K-map are 20 and 28. 20, 28 can be easily combined with 21, 29 for a group of 4. So this is group number 3. Now the one which is left in 18 can be only grouped with block number 2 because it is the corresponding block, and this is group number 4. So how to write the answers? I hope you might be now able to write the answers. For the first group, from A side nothing will come. From BC side, yes, something. From the BC side, C will come. From the DE side, E will come. Now for the second group, the whole group lies above A bar, so A bar. From BC side, B bar, C bar. From DE side, it's E bar. For the third group, it's A, C, D bar. And for the fourth group, it is A, B bar, C bar, D, E bar. So this is the answer. Please check, verify it, and do let me know if you have any doubts. So this was 5 variable K-map. So I hope that you might have got an idea about 5 variable K-map as well. Now let's move on to 6 variable K-map. First of all, let us see the structure of 6 variable K-map. As you can see, that 6 variable means A, B, C, D, E and F. And the number of blocks will be 64. Alright. For 64 blocks, what you have to do? See, I'll tell you a very simple way. we all have seen two variable K-map in the first part of this video. Now imagine each and every block to be replaced by a 4 variable K-map. Each and every block replaced by a 4 variable K-map. Alright, so now let's draw it. So these are the four variables K-map. Let's allot the variables. As you saw in the 2 variable K-map, what did we do? We did A, B, this was A bar, A, this was B bar, this was B. Similarly here, A bar, A, B bar, B. Remainings are C, D, E, F. So C, D, E, F, C, D, E, F, C, D, E, F, and C, D, E, F. Alright, do the allotments. These are the allotments. Now do the numbering. Let's do the numbering now up to 63. Now let's solve a question through this particular structure. Question is y a b c d e f is equal to summation m 0 1 2 3 4 5 8 9 12 13 16 17 18 19 24 25 36 37 38 39 52 53 60 61. This is the question. Let's fill the ones over here. So this is how you will be seeing the structure when you will fill the ones. So always keep 2 variable K-map in rough for your understanding. So when first of all look at the K-map which is in front of A bar, only this particular K-map. Now for this you can easily see that you can find a group of 8. Try to make it a bigger one. How you can make it? If you find corresponding blocks filled with ones either in the adjacent blocks, that means either in this particular block or in this particular block, but you do not have them, so let's make a group of 8. Now only 2 ones are remaining in block number 2 and 3. Let's try to combine them in a bigger group. They can be combined in the group in this particular K-map itself, 0 1 2 3 in a group of 4, but even try to make it bigger one. If you have corresponding blocks filled with the same ones either in the aside this K-map or in this K-map, then it can be grouped into 8, which we found that this can be grouped into 8. Now all the ones in this particular K-map are grouped. Let's move on to the another K-map. In the another K-map, only 24, 25 block numbers are left. Let us try to combine them. If we look in the same K-map, 24, 25 can be easily combined with 16, 17 corner groups in a group of 4. But let's try to, so a group of 4 we have already got. Let's try to make it a bigger one. So it can be made a bigger one because in the corresponding blocks you have again got the ones, so it can be grouped into a group of 8. So this was our first group, this is our second group, and this is our third group. Alright, now let's move on to the another K-map. We have 36, 37, 38, 39. Can it be grouped into a bigger one? No, because in the adjacent K-map also we do not have the ones in the same corresponding block, neither in the above K-map. So it is a group of 4. This is the fourth group. Now 52, 53, 60, 61. It can be only combined in a group of 4 because we do not have the corresponding ones either in the upward K-map or in the adjacent K-map. So these 5 groups are made. Let us write the answers for them. For the first group is 0, 1, 4, 5, 12, 13, 18, 9. So the first thing will be, I am writing the answer here itself, A bar, then from B it will be B bar, then from CD nothing, then from EF it will be E bar. It will be E bar, alright. Then In the next group, what do we have? We have in the second group, the second group is a group of 8. A bar, from B we have nothing. From CD we have C bar, and from CD we have D bar, and from EF we have E bar. Then the third group. The third group, from A we have A bar, from B we have nothing, from CD we have C bar, D bar, and from EF we have. Then the fourth group, we have A, C, from B we have B bar, from CD we have C bar, D, and from EF we have nothing. Then for the fifth group, we have A, B, D and E bar. So just calculate your answers, verify your answers, and do let me know that whether you have understood the 6 variable K-map also, and all the variable K-maps by writing into the comment box. So thank you all. Thank you so much for watching this video. I have mentioned the links of my videos separately, which I have made in detail for all the variable K-maps in the description box. You can also refer them for more questions or detailed understanding. Thank you.